Ethernet cables. Ethernet cables are the most common wired network cables you'll see at home and in offices. These essential connectors use what's known as a RJ45 interface to establish your network connection. When you peek inside one of these cables, you'll discover something fascinating. Pairs of copper wires twisted together in a specific pattern. This isn't just random design. The twisting actually serves a critical purpose, dramatically reducing electromagnetic interference and ensuring your connection stays rock solid and dependable. Now, here's where it gets interesting. Ethernet cables aren't all created equal. They're classified into different categories, which everyone in the industry just calls CAT. You've probably heard of Cat 5e, Cat 6, Cat 6a, and even Cat 8. Here's a simple way to think about it. Imagine these categories as different highway systems. The higher the number, the wider the highway, which means more data bandwidth, faster transfer speeds, and significantly less signal degradation. If you're just getting started with networking, Cat 5e will handle your everyday internet needs perfectly fine. But if you're serious about performance and want to reach those gigabit speeds with minimal interference, Cat 6 is your sweet spot. Now, Cat 6a and Cat 8, these are our heavy hitters. You'll find them in commercial office buildings, server rooms, and massive data centers where performance is absolutely critical. Here's something crucial to remember. Ethernet cables have a distance limitation. They'll work reliably up to about 100 meters, which is roughly 328 feet. Push beyond that threshold and you'll start experiencing signal degradation. Also, if you're planning to run these cables through walls, ceilings, or under floors, make absolutely sure the outer jacket has proper fire rating. This isn't just good practice, it's often required by building codes. Despite the wireless revolution, Ethernet remains the most cost-effective and stable method for connecting your devices compared to Wi-Fi connections. Coaxial cables, which most people simply call coax, represent some of the most enduring and dependable cable technology ever developed for transmitting high-frequency data signals. Let's break down the anatomy of these remarkable cables. At the very center, you'll find a solid copper conductor that does all the heavy lifting, carrying your data signals. Surrounding this core is a substantial insulating material that keeps everything electrically separated. Next comes a metallic shield, either woven mesh or aluminum foil, that acts as a protective barrier against electromagnetic interference. Finally, everything is wrapped in a tough outer jacket that protects the entire assembly from physical damage. This multi-layer construction is precisely engineered to maintain exceptional signal integrity across impressive distances without meaningful speed loss. Historically, coaxial cables powered the telephone trunk lines that connected cities. These days, internet service providers commonly use coax to deliver broadband internet directly into residential homes. You'll also find these cables handling cable television distribution, closed-circuit television security installations, satellite dish connections, and radio antenna systems. The real superpower of coaxial cable lies in that heavy shielding. It makes coax incredibly resilient in electronically noisy environments where power lines, electric motors, or radio frequency signals would normally wreak havoc on other cable types. Sure, coax is noticeably thicker and less flexible than Ethernet cabling, and you'll typically need specialized connectors to terminate it properly. But when your application demands long-distance signal transmission combined with superior noise immunity, coaxial cables remain an outstanding choice that's tough to beat. Fiber optic cables represent a revolutionary departure from conventional copper-based wiring because they transport information using light waves rather than electrical current. At the heart of a fiber cable lies an incredibly thin glass core, sometimes thinner than a human hair, through which precisely timed light pulses travel at extraordinary speeds. Encasing this core is a cladding layer engineered with a specific refractive index that acts like an internal mirror, keeping those precious light pulses bouncing along inside the fiber without escaping. Because the transmission medium is light itself, fiber optic cables can carry signals across vast distances without experiencing the speed degradation or quality loss that plagues copper cables. They're also completely immune to electromagnetic interference that would disrupt copper-based systems. To protect this delicate glass core from breaking or microfractures, engineers wrap it with flexible aramid yarn strength members, often made from materials like Kevlar, the same stuff used in bulletproof vests. Then the entire assembly gets wrapped in protective outer jackets with the specific design depending on the installation environment. Indoor fiber cables are remarkably thin and lightweight, making them perfect for threading through data center racks and building network infrastructure. Outdoor rated fiber cables are much more robust, featuring heavy-duty construction sealed against moisture infiltration, extreme temperature swings, and mechanical stress from environmental factors. Internet service providers, major corporations, and telecommunications companies rely heavily on fiber optic technology to deliver blazing fast internet services, manage enormous data transfers that would choke copper infrastructure, and interconnect office buildings or even span entire nations with ultra-reliable, high-capacity communication networks. Submarine internet cables are extraordinary engineering achievements, massive fiber optic cables carefully laid across the ocean floor that form the invisible backbone of our connected world. These undersea giants transmit internet data as rapid-fire pulses of laser light between continents, literally connecting different parts of the globe. These transoceanic cables handle an astonishing amount of work, carrying roughly 99% of all international internet traffic flowing between countries. Inside each submarine cable, you'll find multiple hair-thin glass fibers responsible for transmitting those light signals. Surrounding these delicate fibers are numerous protective layers specifically designed to withstand crushing water pressure thousands of feet below the surface and resist damage from ships, marine life, and underwater geological activity. Because light signals naturally weaken over extremely long distances, these cables incorporate sophisticated devices called optical repeaters positioned approximately every 50 to 100 kilometers along the cable route. These repeaters amplify the weakening of light signals, ensuring data integrity across thousands of miles of ocean. Eventually, these submarine cables reach shore at specialized landing stations, which are essentially sophisticated connection points where the undersea network interfaces with the terrestrial internet infrastructure we use daily. The critical importance of submarine cables cannot be overstated. They're dramatically faster and can handle exponentially more data volume than satellite-based communication systems, which makes them absolutely essential for bandwidth-intensive applications like high-definition video conferencing, secure online banking transactions, cloud storage services, and lag-free online gaming experiences. Occasionally, these cables suffer damage from dragging ship anchors, commercial fishing equipment, or underwater seismic events like earthquakes and landslides. However, the global submarine cable network includes extensive redundancy with multiple parallel cables along major routes, ensuring that even when damage occurs, internet connectivity continues flowing through alternate pathways. And there you have it. You now understand the fundamental cable technologies that power our modern internet infrastructure. Drop a comment below and let me know which type of cable you're currently using in your home setup. If you picked up even a single new piece of information from this explanation, which you better have, I'd really appreciate it if you'd subscribe to the channel, because my mission is to demystify complex technology and break it down into concepts that anyone can understand. Get it? Got it? Good.